Hello YouTube, Rohan this side. So in today's video, we will be learning about RabbitMQ. And in this video, we will try to learn about what is RabbitMQ, why it is used, and how we can also use it in our Kubernetes cluster as a DevOps engineer. So first is RabbitMQ is an open source message broker software that facilitates communication between different part of a system, or simply you can understand that it is a open source message broker or a queue software which helps us to communicate between multiple part different part of your application or your infrastructure. So it implements advanced message queuing protocol, which is AMQP, and so RabbitMQ acts as a middleman, which receives, stores and forward messages between producers and consumers. So here, producers and consumers, you can consider them as a different service, or if you are very familiar with microservice architecture, then you can consider that you have one microservice, and which is like trying to emit or give some output, and that output is required by your consumer or your another microservice. So RabbitMQ will act as a middleman there, and it will store your messages and forward them whenever it is required to your desired another or microservice. So RabbitMQ also supports multiple message protocols like AMQP, MQTT, STOMP, etc. And it was originally developed by Pivotal Software, but now it is part of VMware Tanzu. So now let us understand why it is used and why to use it basically. So these are the four use cases which I have tried to cover here, but it covers a wide number of use cases. So let's start one by one. One is decoupling your applications. So as I have already explained, that producers and consumers are nothing but two different microservices. Just for simplicity, I am saying here. So producers and consumers don't need to know about each other. So for an example, your order processing system, where the order service and payment service communicate via RabbitMQ. So you can consider that you have different service, where one service is using order processing and another is for payment service. So RabbitMQ will act as a middleman for these two service or these two servers, and will help them to communicate. And hence you can you are not tightly coupling your application, and you can use different servers or machines for each of your service. Another is load balancing. So distribute messages across multiple consumers to balance the workload. So for the example could be processing user upload in parallel. So here you can see means you can consider that a wide number of users can simultaneously use RabbitMQ queues, then to upload their workload, or here user upload in parallel. Another is asynchronous processing, which is improves performance by offloading time consuming tasks. So one of the example is sending emails or notification in the background. So asynchronous processing, you can consider that you don't have to pull or push anything to be get notified. So there that work is handled by RabbitMQ message brokers or queues by sending your data or getting notification from other channel. Another use case is reliability. So it ensures messages are not lost even if a consumer fails. And example is critical financial transactions. So as in the first slide we have seen that it stores the messages, or you can say stores your data. So that's why reliability is high here. because it will store your messages, and none of your message will get lost, even if it is not consumed by your consumer. Okay, so this slide is for why to use RabbitMQ, and this is now we are heading to the core concept, like what are the architecture or what are the basic terminology you will face when you will like implement RabbitMQ in your system. So first is producer. So producer is nothing but the application that sends messages. So for just simple example, you can consider producer as one of a Microsoft. Then the part is consumer. So consumer application that receives messages from your producer. So here also you can consider consumer as a different Microsoft. Microsoft A or Microsoft B, something like this. Now we have queue. So queue is buffer that store messages. And maybe if like you are familiar with queues, so queue is a data structure where where it follow first in first out principle, where we are like storing some data some at some like you can say locations, and those locations are used or implemented in a first in first out manner. So if first message is parked in my queue, then it will be the one who will get out from my queue. Then we have exchange. So exchange is it receives messages from producers and routes them to the queue. So exchange component sit in front of queue, and it is the one who will like receive the messages from producer directly, and then it will route them to the particular queue. Then we have binding. So binding is a link between an exchange and a queue. So binding is the one who will be sitting in between queue and exchange, and it will help the exchange to forward the message to the queue. And in the last we have message. So message is nothing but the data which is being sent between applications, and applications could be our producer and consumer. Okay, so our core concepts I think are clear here. So I will try to reiterate one more time. So producer is nothing but who will generate or who will emit the data or messages here. Then consumer is the one who will receive those messages and then and do its operation on that. Then we have queue. So queue is nothing but you can consider it as a storing location or like a warehouse where it will store the messages which producer is sending. Then exchange is the one who will receive the messages from producer and route them to the queue. And then we have binding. So binding is just a link between our queue and exchange, and message is nothing but the data which is being traveling across this architecture. So now let us try to understand how RabbitMQ works. So producer creates a message and send it to an exchange. Yes, this is what we have learned, like what we have gathered here in the definition. Then the exchange routes the message to one or more queue based on the routing rules. So I will like explain you what are different type of routing rules RabbitMQ provides. So then the queue stores the message until a consumer retrieves it. So here you can consider that consumer is the one who will try to access or ask queue if any message is there or not for its particular operation, or from particular producer it want. Then the consumer processes the message and sends an acknowledgement, and then RabbitMQ deletes the message from the queue once processed. So I have tried to make it very simple that how RabbitMQ works. So let me reiterate one more time in less time. So producer will generate a message or create a message, and then it will send it to exchange. So now the exchange work is to route the same message to one queue or more queue if it is required based on the routing rule we have written. Then as the message is reached to the queue, then queue will store the message until a consumer will ask for it. And if the consumer asks for it, and then it will do its work, and it will send an acknowledgement, and the cycle is complete, and then RabbitMQ delete the message from the queue. So this is a simple diagram, or a simple, not an architecture, but a simple workflow, like which I have taken from internet, and the copyright goes to the respective owners because I don't own this. So here you can consider that we have three type of producer service, or as we are going with microservice architecture, then you can consider service 1, service 2, service 3, and they are creating some data or messages. So now what they have created or generated is going to the exchange, which is part of RabbitMQ. So this square you can consider is the part which is handling by RabbitMQ. So here message is getting received from the particular producers to the default exchange here, and then its work is just to forward them to the you can say queues, and particularly queue, like as this denotes for service 1, so specific queue is there for specific producer here, and then it is able to send them, and the queue thing is to store the messages. Here messages are getting stored, and this is how like a queue works. And so now, as here in this side, you can see that we have 4 consumers or 4 different microservices which will ask for their particular message from the queue, and then it will get those messages, and it will process them, and after their work they will give the acknowledgement, and the message will be deleted. So this is a simple workflow which we can understand from RabbitMQ. So RabbitMQ part is this one, where it is doing all the work for us. So if you will like discard this square part, then we have to use some other operation or some REST APIs to communicate between different microservice or different producer and consumer. So RabbitMQ is therefore very useful here, because it is acting as a central location for every message, or for every producer consumer couple. So yeah, now let's try to understand what are the type of exchanges this RabbitMQ provides us. So it has 4 type of exchanges. One is a direct, which helps us to route messages based on a routing key. Then we have fan out, so broadcast messages to all bound queues. Then we have topic based exchange, where routes messages based on the pattern matching. And then we have headers, which is using headers. So I will try to explain it in more simple terms. So you can consider direct as a exchange where you have already hard coded the thing that my producer 1 will always send the message to consumer 1. Okay, so by that exchange, it will always make a bridge between those 2 microservices. So it is directly, or you can say it is hard coded type of it. Then we have fan out. So in fan out, by this diagram, you can consider that if a fan out architecture is implemented, or fan out exchange is there, then it will broadcast the message which is getting from producer 1 to almost all the consumer which is part of the RabbitMQ or your architecture. So it will broadcast everything. Then we have topic based. So in the topic, you can consider that you can consider a very simple example of YouTube. So suppose there is a YouTube channel which you have already subscribed. So whenever there is a new video or new notification or new post is coming from that channel, then you will be getting the notification for that. Why? Because you have already subscribed to that. So it works on this topic thing. So you can consider that one of the topic which you are always wanting to be get notified. So you will be using this topic exchange. Then we have headers. So in the headers, based on the headers and other backend part, those exchange works. And to be very honest with you, I don't have much knowledge on how the headers thing work. So yeah, so this is a difference part I have created. I know it is not very much required, but maybe you have also heard the name Kafka, Apache Kafka, very much, because it is also a very famous message broker. Here I have tried to make a slide where we are trying to differentiate between RabbitMQ and Apache Kafka, because overall they work the same, but they have their own advantage and disadvantage and their own use cases. So RabbitMQ, as we have already seen, that it follows AMQP protocol, and Apache Kafka has its own custom protocol which is known as Kafka protocol here. And for use case, RabbitMQ is task queues and short-lived messages, as we have seen that after sending the acknowledgement, it deletes the messages and it complete a cycle. Whereas in Apache Kafka, it is a event streaming thing where we are not storing anything, but using a event direct, we are just passing the messages and forwarding them, and it is for long-term log storage. Then we have a message storage feature, which is delete after acknowledgement for RabbitMQ, and for Apache Kafka it retains until and unless we have done some any configuration thing for that. Then message ordering. So RabbitMQ, as we know, it follows queue, so first in first out protocol or implementation. So on that basis it works. And Apache Kafka use partition based ordering. And then for the performance thing, RabbitMQ has low latency and moderate throughput, but for Apache Kafka it has high throughput. So if you want that I can create, I should create a video on Apache Kafka, so you can comment that as well. So I will try my best to bring that video as well. So now we have discussed about what is Kafka, what is RabbitMQ, why to use it, and how we can use that. So now let us also try to understand what is its advantages and limitations. So one advantage is reliable delivery with acknowledgement, which was not case with Kafka. And another is easy integration with multiple languages. So yeah, you can create as we are going with microservice architecture, so you can create microservice with different programming languages, and then also RabbitMQ can make communication between them. And it also supports clustering and highly availability, that I will just explain you how in a short time. Then it has a strong community and ecosystem. So yeah, you can you can join more forums on for RabbitMQ issues, and as it is open source, so community is active, and you can get your replies and your help very easily. So advantages are done. Then limitations. So lower throughput compared to Kafka, which we have already seen in the difference table. Then requires tuning for high scale workloads. So as it provides lower throughput, so for making it highly scalable for high scale workload, so it takes some of complexity. And one more important thing is it is not ideal for long-term message storage. So because after acknowledgement it deletes everything, so for long-term message storage thing, like you cannot use this. So yeah, this was all the theory part which I have like created for Kafka. And yeah, for supporting clustering and HA, so I think we have a RabbitMQ operator. uh, yeah, RabbitMQ cluster operator. So mostly in your professional projects or your professional like workload, you will be using a Kubernetes operator for RabbitMQ, by which you will install a RabbitMQ operator, create your cluster. So cluster here means 2 or 3 workloads for your RabbitMQ, and that will help you to make your RabbitMQ as a more highly scalable and high available as well. So this is the official documentation thing for installing the operator, then like configuring the defaults as well according to your needs, and like how you can use RabbitMQ operator. And I think they also even provide monitor, like how you can monitor. So by using the operator, it will install the custom resource definitions and other related stuff. So this is how like you can use Kubernetes operator as well for this. But for my demo, like I will be using a very simple Docker Kubernetes image for RabbitMQ. I will not be like creating a cluster because it's just a demo part, and we are still learning like how and what is RabbitMQ. So let's start with the demo part. So for this demo, I will not be using any cloud-based or cloud-managed Kubernetes cluster. I will be using OrStack, where I will be doing everything locally in my machine. And this is the repo which I will be following through the demo. So I have created a custom application using LLMs. So if you found any mistake or if you found any error, so please help me by commenting the same in the comment section. And if you want to like contribute or if you want to rectify it, feel free to do that as well. So let me open my VS Code itself. So I have created a different folder for my Kubernetes manifest files, and this is for my application. So I'm using Flask for the backend and simple HTML file for the front end thing. So to create a RabbitMQ connections within your microservices, so you will be requiring this library, which is Pika. So it's a famous, or you can say an SDK for Pika Python RabbitMQ. So this library is the one who will help us to create the connection, and it do all the backend stuff which AMQP does. So here you can see the official documentation so that you can also implement the same. So here you can check out each and every other function if you want to do the thing from your end as well. So as I'm not a developer person, so I cannot like explain you in depth, but what I can do is I can explain you what the code I have generated and what is the application and how we will be doing the POC thing. So in this section we are just importing all the libraries which is required for RabbitMQ and for the Flask API backend thing. After that we are hard coding the RabbitMQ parameters. You can like do it like you can create any .env file for that, but as this is a simple POC thing, so I'm just hard coding the values here. After this I have created a class which is RabbitMQ manager, which will help us to create everything, the queues, the exchange, everything. So here in this we are defining a init function here, where we are just passing these parameters thing, which is connection, channel is connected, consumer thread and consumer running. And after that we have created a function which is connect with retry. So here in this function we are using pika to establish a connection, or connection it is doing all the backend stuff by which RabbitMQ creates to do all the AMQP stuff. So what I mean is this rectangle part which RabbitMQ handles. This is the stuff we are doing here. After this we have created a small function which is ensure connection. So here we are just checking if the microservices or producer consumer are connected or not with RabbitMQ. After that we are declaring a queue, and queue, you like if you have gone through the architecture or the workflow, so you can understand what are the queue here. Then we are creating a function which is publishing messages. So here we are publishing messages to the queue because it's the one who will publish the message within the queues. After that we are creating a new function which is for consumer part, where consuming of the part will start for the consumer microservice. Then it has a child method as well. So here it is doing the same method thing. After this we have a function which is stop consuming, where we will be giving the acknowledgement to the queue, and after that we will give or delete the message. So here we are doing global RabbitMQ manager, initializing it when first used. So here you can see, you can consider that we are just passing the parameters and we are calling the class here, and we are initializing RabbitMQ manager, to be very honest with you. After this we have created endpoints. So one is for the home, where we are displaying, or you can say rendering the index.html or the front end. After this we have a slash health endpoint, where we are checking the health of our RabbitMQ as well as our application. Then in the slash API slash queues, by this path you can understand that we are fetching the values or the queues. So here also I have hard coded the queue which I will be using throughout the POC. After this we have this endpoint which is for publishing the messages from the producer. Then we have the endpoint for consumers, and this endpoint is for making the consumer stop after they receive the message or the data, and to give the acknowledgement as well. And here this is for messages, like here we can check the messages, and here we can check the stats, what is the stat, what is the current message going on, where it is stuck, if it is received by the consumer or not, those values. And here in this last API we are just checking the connection status, by which we will be able to get to know that this RabbitMQ is running or not, or healthy or not, or if it is aborted, or if it is stopped. So this is a very simple overview of this code. I know I have not explained it very fully and in depth, but because I have generated this line by line from AI, so please you can ignore this part from me, and I will explain the other file component as well. So this is a simple index.html. So this is also I have received or generated from AI, where I'm using HTML, CSS and JavaScript part of the front end. So this is the CSS part, and in the um, this thing JavaScript, I have created some tabs and containers where we can look about all the producers, the consumer tab and the monitoring tab. So this is the one I have like created, which I have not seen into very much from other POCs and other YouTube videos. So this is the thing which I can say I have like created by myself, which because it was needed by me. After this, the same JavaScript code to check if connection, what is the connection status, and accordingly we can switch the tabs and like same thing, publishing the messages and start consuming and stop the consumer. Then how the load messages are working. Then we have to clear the message as well. So this functionality is also there, and we can also refresh stats and updating the chart, and yeah, that's all. So this is all about the front end, the index.html file, app.py for the backend thing, and this is the Docker file I have created because I will be running a Dockerize or image part of this application. So this was all about the application thing, which we will be deploying just in within 5 minutes. So now the Kubernetes stuff comes into the picture. So let us start with the namespace thing. So here I am creating a custom namespace which is RabbitMQ here, and by this YAML I think you can like easily understand what I am doing here. After this I am creating a RabbitMQ deployment. So here I am using RabbitMQ official image which I have checked from Docker Hub and all. So this is a deployment thing. I was thinking to have a stateful set for this, but I thought it's just a simple demo and deployment will be fine, so that you can have some basic idea about RabbitMQ and all. So here this is API version as and the kind is deployment. The namespace is RabbitMQ here, and accordingly I have used the labels and selectors as well. Then in the containers I am passing this as RabbitMQ. This is the image which includes 3.12 management, because I would be needing two containers for that. So one container port is 5672 and another one is 15672, and these are the environment variables we are passing, and I'm just giving some resources limit and request for it so that it cannot consume almost everything. After this we have this config map where I'm just passing the configuration thing for RabbitMQ, and namespace is done, and this is the service where I'm just passing or declaring the service, as we are using two containers within a pod. So here I have given two separate pod. One is for AMQP and another is for management. So AMQP, you can consider that AMQP is a protocol which will help us to have a RabbitMQ manager, means the networking thing or the backend stuff, and management is the one who will give us some GUI so that we can have a look into RabbitMQ. So this is for the service. Namespace is done, deployment is done, config map as well, and this is the application which we will be containerizing, and which is I have taken from this folder. So here also I am just passing a deployment which is a stateless application. I'm having a replica of one, and container port I am provided is with 5000, and these are the environment variables or the values I am passing, and yeah, within this I am also passing the service for this, as I'm running it locally in my machine, so I have given it cluster IP. And yeah, so that's all about the Kubernetes manifest stuff I can say. So now let us try to apply these manifest inside the cluster. So yeah, so this is ops stack if you are not familiar. So I will be using this to have a Kubernetes cluster. Okay, so now let's apply everything which is written inside K8's folder. Okay, okay, it was a typo error. Okay, I got it. So first I think I have to manually or apply the namespace file, then only it will apply for everything. Okay, so now yeah, I can see every other thing is created. So let us check in Obstack dashboard what is the status. So I can see that RabbitMQ is up. So let us try to access that. So yeah, and we have to pass username and password here, and we have already hard coded them, so we will be using the same which we have applied in the manifest. Admin 123, not now. So this is the home page of RabbitMQ which we can see, and here connections you can see that four uh, IPs I can see, and the username is the admin which I have used to log in. And here this is the exchange, and I am mostly using the direct one. Okay, so this is the RabbitMQ portal or dashboard we can consider, but it's little bit confusing maybe to you and to me as well, like to be very frank. So that's why I've created this custom application so much simpler, so that I can try to explain what we are doing and what is happening under RabbitMQ. So now let us try to check if the pod is up or not. Okay, so pod is up. Now let us try to access our application. So this is the application I have created, and here we can see that it is connected to RabbitMQ, and we have three tabs. One is producer, another one is consumer, and third one is monitoring. So in the producer you can consider that we have different type of queues here, where the producer will generate or create messages to the respective queue, and that queue is linked for consumer to consume. And here in the monitoring we can check if we are able to if the message is getting generated or not and received by consumer or not. So this is how we will try to do the stuff. So let us try with the test queue here, and let us try to have a message. So message 1 for from test queue. Okay, so now I will click on publish message. Here it is saying message published successfully to test queue, and so this was for queue name test queue. So here in the consumer as well, what we will do, we will select test queue here, and we will click on start consumer. Okay, so here immediately you can see that this is the test queue, and this is the timestamp, and the message which we just generated is consumed by this consumer, which is message 1 from test queue. And if we go to the monitoring tab, here we can see that this is the test queue section, and if we refresh the stats, here we can see that yeah, one message is there. So same thing, what we can do is we will try to generate a new message from orders. Like we will create a new message for orders queue, and then we will go to the consumer section and we will check from there as well. message from orders queue. So message published successfully to orders. We will go to the consumer and we will select orders here, and I will click on start consumer. Yeah, so here also you can see that this is the queue name, timestamp, as well as the message. And I'm not sure, but until and unless I don't click on stop consumer, then some thing get wrong in the configuration. So because I'm not a developer person, so I'm not sure how to rectify that, but yeah, if you know, please help me with that. So in the monitoring, I can see this is the orders queue section, and here we can see one messages is there, and refresh stats and all, like everything is working fine. So now let's try to click on notifications queue name here, and give some message here as well. Message from notifications queue. Click on publish message, and if I click on start consumer, as we have not selected producer, so that's why it is not showing us the message. So what I will do is I will first click on stop consumer, select the correct queue, then click on start consumer, and boom, so here you can see now it is showing us. Let me try to pass another message, message 2 for notifications. Yeah, so this was a thing I was trying to explain you, because if I just click on stop consumer here, and now I will hit on publish message, then everything works fine. And I will just click on start consumer for notifications. So see, the another message is also getting displayed. So here by this you can use RabbitMQ to have a communication or a bridge between your producer and consumer, so that by not blocking your consumer to process whatever producer is generating, you can have a queue in between them, so that it can store your messages, your data, and when you want to consume them, or whenever you want to whenever you want to use them or you need them, then only you will just click on start consumer, and then only the received message you will receive, and you can work on that whatever your need is. And in the monitoring also I can see that it is showing the correct messages, because for notifications we have passed 2 messages, and for remaining one each. So this is the simple application I can say which I've created for this video. And let us try to check what is happening inside RabbitMQ management. So here also we can see many of the work is done, and these are the channels, queues. Yeah, so in the queues and streams we can see these are the queues, the queue names which we are using. So let us try one thing. So here as we can see that in the queues and streams it is showing us the queue names which we are using, and here it is saying or displaying that the messages are ready, unacknowledged, and total. And here in the each of these columns it is 0. So let's try one thing. Let's try to generate some message from the producer, but we will not start the consumer to consume it. And let us try with this order. So new message for order queue to test the management, MGMT. Yeah, let's publish this message. Yeah, so this message is published for orders, What happened? Okay, stop it. And yeah, see, without refreshing it, because it is refreshing after each 5 seconds, and here you can see that for ready it is saying that one message is in ready state, but it is not yet acknowledged. Why? Because as we have not started consuming for that queue, and so let's try to do the start consuming for that. And as soon as we start with this, then this message will get acknowledged, and this ready value will become 0 again. So start consumer. Okay, so here you can see this is the message I have passed for the queue, and boom. So here if I will refresh, then here also it was ready earlier, but now as we have consumed it and acknowledged, so it is done. And okay, let us try to generate a new queue. I'm not sure if it will work or not, but yeah, arguments. Okay, let us add that. Okay, okay, so I'm not sure if it will be visible here or not, but yeah, because as I have like explained that in the application, in the app.py, I think in the array where we are passing all the queues, um, 1 second, test queue, yeah. So I think as I have hard coded the values for the queue names, so that's why in my application it is not visible. But yeah, here in the management I can see that this new queue is visible. And so today I also got to know that we can create queues from RabbitMQ management portal also. So this is how also you can create a new queue or add a new queue. If can we delete it, that I am not sure. Okay, let it be. So yes, so this was all about the RabbitMQ, which I have also learned through creating this video, and I hope I was able to explain you the thing which I wanted. And I hope you will like get some basic understanding of how RabbitMQ works, why we require that, and what will happen like if we don't use that. So thank you for your time, and have a nice day. Bye.